let's finish off question 8 then. So if you've got 13 customers and their mean score is 52, then if you multiply these two numbers together, you get what all the customer scores add up to. Because if you divide this by 13, you'll get 52. So it's just kind of doing the mean backwards. So we need 676 in total. Add up what you've got, take that from 676, and you'll find out that the two missing ones, M and S, is 142 altogether. So that's useful to know. Then the only other bit of information they give you is that the median's 54. So if you put them all in order, just the ones that you've got, leave out M, leave out S, you'll notice that the median is only in the middle there, so only 54. This one here is only in the middle if S and M are both above 54. So that's something useful to know as well. So they both have to add up to 142. They both must be bigger than 54. They can't equal 54 because they all have to be different. No two scores were the same. So the least value that S can be is 55 because it has to be bigger than 54. But then we could say, okay, what can the greatest be? So we say, right, it needs to add up to 142. If we want S to be really big, then we want M to be really small. So we make M 55 instead, and then just subtract the 55 from the 142, and you get 87, and that's the most that S can be. So that's that one. Right, on to probability then. As probability goes, this one's quite nice. Whenever you've got money and throw my pencil around. Whenever you've got money and probability, you're going to be multiplying them together, so expected values. So for this one, they're talking about whether to replace the head gasket or not. So here, if you replace it, it's going to cost you 1,450. It still might break though, so your probability has gone down, but it still might break. You take that probability and you multiply it by 20 grand, and then add it to the 1,450 that you've already spent. So that makes 1,450. If you don't replace, or no replace, then you just take your probability that they give you, so in the table 0.095, and you just multiply it by your 20,000. That makes 1,900, which is more. So normally you want to spend less money, so this is better. So you want to replace it because this is smaller than this. So should replace the head gasket. Okay, down here. Work out the probability that at least one of the events in the table happens. Okay, so at least one of them happens. So that could be the head gasket breaks, or it could be the timing belt breaks, or it could be the air filters breaking. Now at least one, so that doesn't just mean exactly one, it could be two or three. So it could be the head gasket breaking, or the timing belt, could be the head gasket and the air filters, could be the timing belt and the air filters, could be all three. I'm working out all of these because there's sort of 1, 2, 3, 4, 5, 6, 7 different things there. It takes a lot of work. You could do it would just take you a long time. So it would be better to say, well, instead of going with this and working out 7 different things, what's left? So the what's left is nothing breaks. So if we work out what nothing breaks is, then the rest of it just adds up to kind of the 100%. So let's work out the nothing breaks. So nothing breaks is 1 minus the probability of the head gasket, which is this number. So it's 1 minus 0.095. Do the same with the timing belt. So 1 minus 0.041, and then 1 minus 0.073 for the air filters. And you just multiply all these things together, because that's that not breaking, that not breaking, that not breaking. So this here, 80%-ish, is the probability of nothing on the car breaking. So then the question asks you, well, what's the probability that something breaks? Well, it's not this 80%, it's the rest of it, it's the 20%. So you do 1 minus your 80% and you get that. So 0.195, answer correct to 3 decimal places.